Okay, so what I want to do now is implement the value iteration algorithm in NetLogo and show you an example of how this works. So let's go over to NetLogo here. We got nothing here in the code section, nothing here yet. Let's add our buttons. We're going to need a setup button for now. And the basic what I want to do is I want to have a world with the turtles in it, and it's going to be a two-dimensional world, like that logo is. I'm gonna get rid of the wrapping, so it's a fixed world. Can't go outside, and so some of these patches we're gonna say are green, some of them are red, some of them are white, and let's say that the turtle is moves around and gets a reward when the turtle hits a green patch, and gets punished, gets a negative reward when it hits a red patch, and otherwise gets zero reward. So let's start by setting up that world. So the setup function is gonna have to ask the patches to set the colors appropriately. So we're gonna set these randomly. So let's flip a coin and let coin be random 10. So it's a number between 0 and 1. If coin is 0, then set p color to red. If coin is 1, the patch is going to set its color to green, and otherwise it's going to set its color to white. So put that up here. Set color to white. Okay, so let's see, that works. Boom. Okay, that's working nicely. Now, move that over here. So we're gonna need now, the idea is we're gonna have what we want is a utility function that matches each state of the world to an action, right? So we're gonna need this U of S function maps the state of the world to a utility, using this equation. And what we want is first we gotta set up the rewards, the R of S, right? So before we do that, we have to define, okay, what is the state here exactly? So we're gonna have a turtle that moves around this two-dimensional world, right? And so I'm gonna say, just put a comment here. So the state of the world is, the X and Y location of the turtle, right? So that's basically it. So where in the world the turtle is, plus also the heading, because the other thing I want to define are the actions, right? So going back to our algorithm here, we have to consider what are the agent's actions. So what I was thinking is for the actions are going to be go forward 1, left turn 90 degrees. So the turtle turns 90 degrees to the left, or the turtle turns 90 degrees to the right. So those are the 3 actions. It's a little bit different. Normally you have actions of north, south, east, west, but I'm just doing it a little bit different here. So there you go. We have 3 possible actions. And so the state of the world is going to be the X, Y coordinate of the turtle, and also what heading it is at, right? Because it could be, the heading is the direction the turtle is facing, right? So I'm going to assume, because of the left turn, right turn, that the turtle can only face 0, 90, 180, and 270, right? Because it can only change by 90 degrees. Okay, so that's the state of the world. We have our state, which is all possible X, Y combinations, and our 3 actions. So what's next? Let's see, what can we do? Well, let's talk about this utility function. So the utility function now is going to be a mapping, from the state, which is these 3 numbers, X, Y, heading, to a number. Well, this doesn't show it, but it's a number. So how do we do that? Well, we're going to use, over here. We're going to use a hash table. Hopefully you're familiar with them. NetLogo has under here, under extensions, array, and table. So a table, what they call a table, is a hash table. And here it shows you how to use it. If you're going to use the tables first, you have to add that line, extensions table. So I'm going to add that line, table. And then, so there you go. So now you can use it. And now these are some of the commands I can now, to create a table, I say table make, and then table put. I get my key, for my table, my key, and the values. And that's how it puts there. And then I can get things, table, key, and it returns the value. So it's a key value mapping. So what we're going to do is we're going to use a global u, right? So that's u is our utility function, just the same as here, right? That u, that's u, u is u, u is u. So now I'm going to need a couple of utility functions here because I'm using the state is composed of 3 numbers. I'm going to need 2. Oops, where am I? 2 put utility. So when I want to put a utility, I'm going to need the key, or sorry, x, y, and dir, because the word heading is taken. X, y, dir, and then the utility that I want to store. So that it stores. It's going to store the utility in the state. So I'm going to let the state be the list of x, y, and dir. Right? So you see what I did? I put these things together. I'm going to use that state as the key. And then I could do table put. Wait, did I get that wrong? I think I did because it didn't turn color. Table get table column put. No, that's right. Table put table key value. Right. So okay, that kind of works, but to remember that here we have to set u to table make, right? Table make. So when we call setup, we create a table, then we can put things on it. Let's see. So setup works. I do u. There's an empty table. That's good. I'm going to click over here. So it's easier to see that. Okay. So I got the empty table, and I can put stuff in the table. Table put. I need x, y, dir, and then the number. Table put, that didn't work. What happened? Put utility, sorry. Put utility is the name. U. There you go. We got a table. So that seems to be working. Okay. Now one thing is put and then utility get. Get utility to report. Get utility and x, y, and dir, and that one's going to report the utility. So it's going to do a table get u. Okay, that's odd. This one changed purple and that one's still blue. I don't know what that is. Table get utility x, y, dir, and these have to be in a list, right? X, y, dir, and I want to return those values. Report. Right. And so that's going to work. Hopefully. Now, yeah. So that should work. But the thing is, what if these guys don't exist? It's going to return an error, right? So get utility 1, 2, 2 is gonna give me an error because it doesn't exist. So what I want to do is for this utility table, and this is one of the things that is not clear when you look at the algorithm, but so initially this utility value should all be some number, let's say 0. So they should all be 0. So this should return 0. And so what I'm going to do is the following: if table colon has key. So there's that one. And okay, I need to create a key here. So list now let the state, this is before, be the list of x, y, and dir. And if the table has that, then we're good to go. We can return it. But if not, then we're down here when we're gonna put, right? So we're gonna put utility. I'm gonna call our guy there x, y, and dir, and with a utility of 0, and we're gonna report 0. So that way we add it. So next time, it's there. Don't have to do that. I guess it doesn't matter. So now we have 2 utilities. Put utility. I can put stuff in my table. I can get stuff from my table. Good. We're making progress. Right. Yeah. Thank you. Need a U there. Okay. So this works. Okay. Next. So now we're gonna go over to my value iteration algorithm. And look at this. So we got this. Now we need a reward. We're going to need a reward function. And that is going to be a turtle function. So because it's the turtles give us the reward, or the turtle is in the spot. So get reward. The turtle, by being a spot, gets a reward. If the spot is green, then if p color, the turtle is sitting in a patch that is green, then we're going to give it 10, a reward of 10. If the turtle is sitting in a patch that is red, we're going to give it a reward of -10. That's lava, it burns. Otherwise, we're going to give it 0. So that's our reward function. We got to turn colors into rewards. Next. That's our reward function. Now we're getting closer to the value iteration. So I got this. So the gamma is going to be a constant, and the epsilons are going to be constant. Let's just put those into the interface here. So we can add these as sliders. Gamma, minimum 0. Gamma has to be between 0 and 1. 1.9. That's gamma, and so epsilon is the error we want. 0 increment is going to be by 0.01. Maximum is 1. Let's say we want an error of 0.1 by default. So that's good. Okay, I got those 2. What else? This is part of the code. Okay, we're good. So I think we can now maybe start. I think we're going to need some other stuff here. We can start implemented value iteration. So the way, the value iteration algorithm, we're going to sort of just copy some of that stuff, right? So we're going to say delta is 0, let delta be 0. And so notice this loop, it says for all states, right? So overall states, we're going to have to do this. So for each one of the states. So now I could go ahead and do a loop here, a couple of for loops. I could do that, like a for each with a list going over all passages, over all x, y combinations. But I think a faster way is just to ask patches, because the states, are really just the patches or the patch locations plus the heading. So we're pretty good there. So ask the patches. So each patch is now going to have to go over the four possible headings in it. So as patches is gonna, this is gonna mean, go for each patch, right? So we're gonna cover all possible X, Y locations. But then for each one of those, I need to cover all the headings. I want to put this here in a global also. The headings, I mean, since we're talking about that, the global, the headings. This is the set of possible headings. So the set of possible headings be 0, 90, 180, and 270. And also we added the actions. It's going to be the list of forward 1, left turn 90. Yeah, these are NetLogo commands I'm typing right here inside a string. And because NetLogo lets me get away with that stuff, you'll see. Actions. Okay, so I got, these are my headings, my action, just 2 global variables I'm going to need here. So as patches, because the next one I needed is for each patch, then for each one of the headings. So for each, in headings as my global variable. So for each patch, for each one of the headings, now what I want to do here is, I want to update the utility for this state. I want to update it with the reward for that state, plus this part. Now let's look at this part over here. This is what's the best action, given that you're currently in the state S, and for a possible action, and given the current value of utility. So what's the best action in your current state given the current utility? So let's see. So for each one of the headings, what is my best action? So here's the situation. I'm in this patch here, so I could, I know px core and py core are the x and y locations, right? And so I would have to check, okay, px for each one of the headings, and then for each one of the actions, which one is the best action, right? So for each one of the headings, and then for each one of the actions, which one is the best action. What I want to do, so I could do this with some math. I could say, okay, if px core and py core is 0, 0, and the action is forward 1, then move the guy forward, or I have to calculate. So forward 1, if he's heading north, then that means that the y coordinate changes. So I could sort of simulate this, but that's just very complicated. Why simulate it when you can just do it? So we're just going to do this in the NetLogo itself. We're just going to let that NetLogo do the forward 1. The way I'm going to do that is I am going to create a temporary turtle here. So I'm going to let my turtle, I have to be 0. This is a little trick here. Create turtles 1. And then I said my turtle self. I haven't found a better way to do this. But if you do that, then now the my turtle variable down here can be used, and it's that one turtle. The other thing I want to do up here, though, is set hidden to true. So that turtle is hidden, it will not be displayed. And then, at the end, after all this is done, I'm going to ask him to die for me. Ask my turtle to die, because we don't need him. Just a temporary turtle I'm going to create and use in this loop here. And this turtle is going to, for each one of the headings, right here, the turtle is going to set its coordinates. So I'm going to ask my turtle to set xy to be my x core and my y core, and x core of myself and y core of myself, and then I'm going to ask him to check find the best action. But what I know from, because I did this before, is that this is better to move this down. Well, it's just going to be easier to move this down, this whole thing, to its own function. So I'm going to create a new function here that's going to do all this loop here. It's going to be called get best action, and this is a turtle function, and it's going to take as an argument. Well, I don't think I need much, right? So I'm gonna ask my turtle. Well, I'm gonna have to do this now. I'm gonna have to save these. Let x to be x core. Let y to be y core. Let dir to be the heading, the current heading, which is the question mark, right? So I have a question mark matches the current heading, and then I can ask my turtle to set xy to be x, y, and dir. I'm sorry, no, can't do that. Set heading to dir. Like I said, now the turtle sets itself, and then I am going to get the best action. Again, because I want to save this, I need best action there. Set best action to get best action. Right. So this is the move. The for each, I'm going to move out of here. Okay, so ask my turtle to get the best action. So here we are. Now all this has to do is going to report the turtle's best action given its current x and y and heading, given its current setup, heading, and the current u. Right, so it's the best action given the u value. So for each one of the actions, again, the thing the turtle is going to have to do is to remember, let x be x core, let y be y, let dir be heading, because we're going to be changing these. So for each one of the actions, I am just going to run it. So turtle starts here. We run it. X. Let's just set this because it's going to be a loop. This is going to need some cleaning up later on. So we're going to run for each one of the actions. We reset the turtle's location and direction. We run the command. It's going to be one of those 3 forward, left turn, right turn. So now the turtle might be somewhere else, right? He might be in the same spot, right? Depending on whether he's at the edge of the world or not. Or he might be turned around. And once that's done, then I'm going to be able to get a reward. So now he's at the new spot, and I can say, give me not the reward, but the utility of that state. Sorry. So the best action is going to depend on the utility of that state. So I need to call get utility of the new state. So get utility xy dir. So get utility of the turtle's current x core, y core, and heading. And that's going to be its new utility. So now what we want here is we want the best action, right? So I need to let best action is going to start 0. Let best utility value big negative number. So let u the utility of current action, utility, the utility of this action is that, right? So whatever this action, question mark, and its value is going to get put at that. So if the utility of the action is bigger than the best utility we found so far, this is just your standard go through, find the maximum. Then I'm going to set the best action to be that one we just did, and set the best utility we have found so far to the utility of action. There you go. And then at the end, when we're down here, then we can just report the turtle best action given its current, and report best action and utility. So this is actually going to report the list of best action and its utility. There you go. So it's going to report the list of the best action and the utility of that action. How good was that utility action for us? Let's check. Okay, so I got a problem here. Best action. There. Utility of action. Sorry. It should be best utility. Check. Okay. So get the best action, reports the best action and utility given as current. So let's test this out. So get best action is going to be a turtle function. It's not going to do anything. Well, I need to create a turtle. For each action, okay, actions should be defined. So it's set up first. Okay, now it should be defined. Okay, so something's working. We have the best action and utility of 0. That seems reasonable. We won't know until we test it all at the end. So, but this is a turtle's best action. If we go back to our here, this is this max, right? So the max over all actions. So from here, this part here, the max over all actions. So and then the sum. This the transition probabilities. We actually use the real world. So we placed the turtle in state S, had it take action A. We figured out where it ended up at, and because in this case, in our world, it's completely deterministic, right? So there's only one final state. We don't have to worry about multiple, a turtle taking an action and maybe ending up in 2 different places. And then we use the utility of that new state, right? So that's when the utility of the best utility, the utility of the action, and we call get utility on the new state, right? The X core, Y core heading. This is after running the action. So this is the magic here. Take action, and if you haven't read about it, so in NetLogo, the run command. See here, the question mark is going to be something like for the string forward 1. So if you say run forward 1, it will actually run the command forward 1. So we can do fun stuff like that. Okay, so that's the get best action, which is a turtle method. And now you'll notice one last thing is so we save is X, Y, and direction, right? And each time through a loop, we have to reset the turtle because it might have moved. So we also have to do that at the end, right? So at the end, we also once again have to set XY back to where it was because we want this turtle to, at the end to be at the same spot because we keep changing its X and Y and heading because of this run command. I'll make sure that at the end the turtle is back to where it should be. So a little premature optimization here. I can move this down here, place that the first time he's going to be at the right spot, and then for that, so now we don't need it. Just cleaning up a little bit. Okay, so get best action is going to return us this list, best action and its utility. So up here, set best action, get best action. Is that right? Right. So what I'm doing here is for each one of the patches, for each one of the possible headings, I'm going to save the X and Y of that. So I'm going to set the turtle to the proper XY and the proper heading, which is in there here. And then I'm going to get the best action for that turtle, which is really the best action and utility. And in this case, what we need is the max. So we only need the utility. We don't actually need the action itself. So best utility is going to be actually item 1 of this list. So remember, this returns a list of an action and utility. So we're going to get the first item, which is the second one. Item 1, the 0, 1. So this is going to return us the utility. We're going to store that in the best utility. So that's going to be all this. And we need to multiply that by gamma, add it to the reward, and put that in the new utility. So how do we do that? We're going to let, well, what is the reward, right? The reward is get reward, right? We already did that, didn't we? Get reward, right? So I can just get reward, and that'll give me the reward for the current state. Well, actually, so the reward is a turtle. So I have to do that over here. Action. Now I know after this the turtle is still in the original place, so I'm good. I can do get reward here. That's going to give me the reward for that turtle for this state, X, Y, and deer. And then it's plus gamma times is the reward plus gamma times the best utility. Right. And all that is going to go into, we're going to need to put utility, right? Put utility, XY deer, and then new utility. So put utility, where was I? Put utility XY deer. And the new utility is this. We're going to put it parentheses to make it more obvious. Put utility XY deer. So that's going to update. This is where I'm updating the utility function. Go back to algorithm. So that's going to update the utility function. And then, okay, the next thing, so that's line 5, then we move to line 6. If the difference in utility is more than delta, then delta is going to be the absolute value of the difference in the utilities. So that means I'm going to need to remember the current utility of XY deer. So probably here. Let current utility get utility X Y deer and new utility. be this. And new utility there. Current utility, new utility. And so what I want is the difference, the absolute value of the difference is between those. So if the absolute value of current utility minus new utility is bigger than, yeah, bigger than gamma, no, delta, right? If it's bigger than delta, then delta is that difference. Then delta gets that number there. Is that right? That's right. Yep. And then so this is so that's it. That's it for that part. And so then at the end of the repeat, we're gonna repeat this until that delta is less than that number there. Um, Let me see. Let me just check this. So best utility, nothing. Best utility has been fine. I'm gonna do let here. Expected command. I'm sorry. Set delta. That was some sort of Java thing. Okay, so value iteration should work. Now it's only going to go through once. It's going to go through the loop once. So I have u. If I call value iteration, it doesn't like this. This code can be run by a patch. Yeah, that should be px core because it's a patch py core. Let's try that again. This is where having this is nice, and now you see the table was empty. Now it's got stuff in it. I run it again, and you see the numbers are changing. That's a good sign. Not sure if they're changing to the right thing, but hopefully they are. And so now you see it only does it once, right? So looking at our algorithm, what we're doing now is we're only doing we don't have this repeat loop here. Repeat until, and then there's no repeat in NetLogo. There's a while loop, so we're gonna have to do that. So I'm gonna say while. Oh, that's the condition. While delta is less than epsilon times 1 minus gamma divided by gamma. While delta is less than epsilon times, I forgot, 1 minus gamma divided by gamma. While that is true, I'm going to run this whole ask patches. Right? And then I can indent this thing, edit. Command, right? Another one. Good. So initially delta is 0. So and epsilon is gamma is not 0. So yeah, it's going to be true the first time around. What we can do here is ask patches. At the end of patches, I can type in show delta. So the idea is that delta should keep going down all the time. So let's try that. Up, and I'm going to go value iteration 45. That didn't work. What's going on? While epsilon, gamma. So all this value is correct. So gamma is 0.9, epsilon is 0.1. Those seem reasonable. And delta was 45. Wait, I think I got it wrong. So until, while, well, it's bigger. While delta bigger. Then it's not going to work the first time around. If I do that, probably not. Just not gonna work the first time around. So what I probably want to do is, oops, I just set that delta instead of 0 to be a big number, like 100. Um, 1,000, so it goes through, and then I'm gonna set delta to 0 here. Because, well, it's gonna get set down here. Anyway, if I set it to 0 here, so I think that'll be okay. You gotta do these things when you don't have a repeat loop. 46, it's going down, down, and stopped. Good. So it looks like it's working. It's converging. It stops. This is the delta. And you see, you notice 46. It goes up to 58, and then kind of seems to go down mostly monotonically. I think the algorithm should always go down monotonically, and the real algorithm, but which is not what we implemented. You see, we did not implement line 2 here. Look at our algorithm here. We're not actually copying the U to another U. We're using the utility, the U in the both the put utility and the get utility. So we're not actually doing this exactly, because this would require copying the whole hash table into the new U, right, every time. And I decided not to do that because there's no built-in NetLogo function for copying a hash table, making a copy of it, and so we're not doing that. And I think it seems to work anyway. Obviously, what's happening is because we're not copying it, then some values, some keys are getting updated in not the right order. So I think that's why you get the up. And the first step usually goes up. Okay, so that's good. Since we're in NetLogo, we can try to visualize that real quick. Put a plot here, plot gamma, and so here, edit that. I'm not gonna plot that. I don't need that. And it's not gamma, it's delta. I'm gonna plot delta. Back to the code here, instead of show delta, plot delta. Setup. Okay, let me add a button. Value iteration button. So setup, call value iteration, blah blah blah, go down, 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 and so awesome. So okay, how do we know this works? And I don't know. Hey, we can run it again and go. I should do a clear all plots, I guess. On this setup, clear all. So how do we make sure it works? What we want to do is put some turtles in there. So put a slider here with a number of turtles. Num turtles, minimum, increment, maximum value. Let's start with 1. 50. Why not? I can just change that here. Uh, okay, so there's my it'll be easier. It's hard to. So setup on setup, I'm gonna create a table, and then I'm gonna create turtles, num turtles, and let's set them to blue so I can see them, and set heading to one of headings, so it's pointing in one of the right places. I think that's it, right? So when I set it up, there's a blue turtle. And okay, so now the turtle is always in the middle. That's kind of okay. So if I do value iteration, what I want to do now is after this is done, I want the turtle to use the U values and pick his best possible action. So what should result is the turtle should basically go to the closest green spot. Let's see if that happens. So this is going to be a turtle function, get reward. See, I already have get best action. So take best action should be easy. This is why I put this here as a separate function also, because I knew I was going to need it when I was going to animate the function, the turtles. So let best action is going to be the first of get best action. So now I don't need utility, I need the action. And bada bing, run best action. I think that's it, right? I get the best action and I take the best action. Not much to it. Okay. Put a go button now. So my to go button is gonna do the usual tick. Okay, so that means I need to reset ticks up here. So that's the clock. Then the clock goes tick. So every time you click go, the clock is gonna go up tick, and then I'm gonna ask all my turtles. It's only one, yeah, but hey, to take their best action. That's it. I think. No. Ah, this is not. It should be the 2. And then I'm going to get a go button. Go. Set up. Value iteration. So that calculates the U utility vector. Until it's done. Now go. He turns right. Goes there. Goes up. Goes up. Goes up. Do you see that? And now, okay, turn. Oh, this worked. Awesome. So now, he's stuck in the green, as you might expect, because he's getting a reward. So set up, value iteration, wait, and go. Yeah, pretty easy there. So now I can increase the number of turtles. Now, yeah, they're all bunched up there, so that's not good. Let's just move randomly. To set up, they're going to be blue, but let's say random px core and random py core should do the trick. So when I hit setup, boom, value iteration. And since the U is global, all these turtles are using the same U, so we only need one U. Notice how you see there was a second uptick. Yeah. Go, go, go. So they're all going now to the closes, and they're going to get stuck in the green. So I think it works. This is not proof that my program is correct by any means, but the fact that all the turtles seem to be going to a green spot and not a red spot, it's all good. It's a good indication that our program works. So that's value iteration. Now you might be asking, well, okay, a realistic situation, the turtles get to the green spot and then they eat all the lettuce there, so it's not green anymore, and now we change it. So what happens? Yeah, I mean, what you could do here is you could take this program and say once the turtles are here, that patch turns white, and then of course because it turns white, we're going to need to rerun value iteration. But you already have that, so you can do that. Okay, so I hope you grab the code and play with it and have fun with it. I'm going to go try that out now. You can spend hours of fun just playing with this stuff.